Good morning. Today we'll be talking about the digital forensics analysis of a ransomware attack. My name is Arnav, and along with my colleague Bikash, we'll be discussing the ransomware attack.
Digital forensics is the process of identifying and analyzing data. Our case study deals with a ransomware attack. We'll be looking how our device got infected by the ransomware, what it did once the device was infected, what data was affected by the ransomware, and how the ransomware was removed.
Before we talk about our case study, let us briefly discuss the importance of digital forensics. Digital forensics is important for many reasons. However, its most crucial application is the study of recovery of data. With malware being developed at an ever faster rate, the study of how malware affects data has become more important. By studying how certain malware attacks work, forensics investigators are able to deploy new ways of data recovery, which can be used to recover confidential documents. The scenario becomes more important when dealing with large organizations who could incur huge losses if crucial data gets lost because of malware. Secondly, by studying malware and its effects, forensics investigators are able to create software that are able to scan and analyze data in real time and more effectively prevent breach from happening in the first place. A third important aspect of digital forensics is the guidelines that it has given us. The guidelines show us how data should be monitored, how data should be kept, and how data should be transported.
Ransomware is a type of malware attack in which the attacker locks and encrypts the victim's data, important files, and then demands of payment to unlock and decrypt the data. A second type of ransomware attack may require a person to perform a certain action or do a task for the data to be decrypted.
For the purposes of our presentation, we have used the WannaCry ransomware. WannaCry ransomware was first published and activated in 2017. It quickly became the most infamous ransomware of all time. WannaCry works by encrypting data as well as propagating through a network as any other worm would. So, WannaCry can be considered a worm ransomware malware. WannaCry encrypts the data, files, pictures, any information on a computer and demands a payment of approximately $300 for the data to be decrypted. There are a few ways in which the data can be decrypted. We will talk about that later on in our presentation.
For the purposes of this presentation, we have used a Windows 10 device. We choose to use the Windows 10 machine as it is still vulnerable to our malware, while also being a modern enough operating system to emulate a real world scenario closely. The device resembles something which would have been typical when the malware was released around 2017. It has a 2 GB of RAM and 225 GB of storage space. While a larger storage space could have been used, it would have been unnecessary for the demonstration. Furthermore, having a modern device allowed us to implement security features which would otherwise have been more difficult to implement. This made a recovery of lost files a lot easier. Since it would have been impractical to use a physical device, we used a virtual machine with the above specifications.
The preparation for this attack or this lab was done in 4 steps. The first thing we did was plan for the recovery of the data. There are applications such as WannaKey, which are able to bypass WannaCry. However, since we may not always know what malware affects our systems, we went with a more practical approach and made a recovery drive which was kept off-site in order to recover the data. The second thing we did was create files on the computer. By creating these files, we could show that the malware had actually taken hold and the files were corrupted. The third thing we did was disabling the Windows firewall. Since this malware was released in 2017, Windows Firewall is very well aware of this malware and is able to detect and disable it very quickly all on its own. However, since we wanted to actually affect the system with this malware, we decided to disable the firewall. The fourth thing we did, which was the final step, we downloaded the malware and got ready for the lab.
We will now begin our analysis of the case study.
For our case study, as we've mentioned before, we infected our device with the WannaCry malware, WannaCry ransomware. Once WannaCry was activated, it encrypted all of our files within a couple of minutes. We were locked out of our device. We were not able to use any of the files that were present. Luckily, we were able to still use the internet, which is what we would have used to download something like WannaKiwi if we wanted to go through that route. However, we soon realized that when we were looking through the internet to try and find other ways of bypassing the WannaCry malware, WannaCry crashed our systems. We were not able to restart our systems, and WannaCry had destroyed all local saves, all local uh, files. WannaCry was able to delete our local backup of our files. Therefore, we had to use our off-site recovery, our backup USB, in order to recover the data that was lost. After we had recovered the data, we found out that must have had an off-site recovery because WannaCry has always deleted local recoveries.
Through the analysis of this malware, we have discovered the importance of continuous backups. Having an offsite backup which is updated regularly may be one of the only ways in which data can be recovered in the case of a malware attack. It can also be said that it was the work of forensic investigation that led to the undaring of the importance of not storing data on site, or more specifically on the device itself. A further appreciation of endpoint security is also evident. Thus, there are two major takeaways we have from doing this investigation. First, bring that data should always be backed up, and secondly, we should always have an antivirus enables. Thank you for listening. Have a good day.